Hello, everyone. Now let me introduce a commonly used model in biomechanics-related applications. It's also a model set that comes with our system. It's called the Helen-Hayes model. There are 3 types of Helen-Hayes models. One is purely for the lower limbs. Another is for the whole body from the shoulders down, and the third one is for the whole body, including the head. First of all, let's introduce the lower limbs. Normally, when doing biomechanical analysis, we usually don't put the person in a tracking suit. It's best to attach the markers directly to their skin or put them in an athletic corset so that we can attach the markers to the body. This way we can get the best data. But because of the cold weather, we're going to use a motion capture suit today. Let's do a demonstration. First of all, we start with the waist. We need to attach markers to the left and right anterior superior iliac spines. We can feel the anterior superior iliac spine. It's a prominent place on the waist. You can turn around. On the posterior side, it's attached to the 5th lumbar vertebra. And this place, I think it's a little loose here. Let's look for the position. We stick it on the surface of the 5th lumbar vertebra. If we use it normally and it's loose like this, I'm sure it won't work. I'll tighten it a bit. Then turn around to the side, and then we'll start with the knee joints. We'll put markers on the inside and outside of his axis of rotation. We can let him bend his knees. Let's find out which axis his knee joint rotates along. We'll put markers on the outside and the inside. We can put them on the other side. Turn around. Then the ankle, medial, and lateral. For the ankle, we usually look for the raised bone on the side of the ankle. Place the marker in the center of this bone. Next, position it on the top of the ankle. Then place it on the top of the foot. We put it at the base of the 2nd and 3rd toes. I'll use a substitute one first. Then we can place it on the heel. We need to attach it at the point at the same level as the toes. Then stick it directly on the lower edge. After the joints, we can place markers on the thighs and calves. Generally, we position them at the center of the thigh, slightly lower down. We need to pay attention to the left side, placing it slightly higher than the right side. Let's say the left one is here. The right one will go a little lower. The center of the thigh is the same for both sides. It's the same for the calves. Just a slight difference in height is enough. For the lower limbs, this is how it looks. There are 19 points in total. If we need markers for the upper limbs too, we add 7 more points. First, the acromion. On the left and right sides of the acromion. Then, the lateral epicondyle of the humerus at the elbow. Next, the wrist. Place the marker at the midpoint of the radial and ulnar proximal
Lift the arm up.
processes. And then on the back, we'll place an offset point. The offset is used to differentiate between the left and right sides. Usually, we place it on the right side, the shoulder blade area. For the upper extremities, these are the points. That's an increase of 7 markers. If the head is also needed, we'll place 3 additional marker points on the head. First, the top of the head, then the front and back of the head. We pay attention to these 3 points on the head. Let's try to keep them aligned. The front and back of the head should be at the same level. We'll ensure they have a uniform height. You can turn it sideways. Look at the front and back of the head. They are at the same height. Now we're done with the markers. We can now let the subject come to the center of the field to get ready. Before we can collect the data, we need to calibrate. If we're talking about gait analysis or motion analysis related applications, we need to calibrate with the z-axis pointing upward. Our x-axis should be oriented towards the direction of motion in the gait analysis. Now that we've attached the markers to the subject, we can move him to the center of the field. You can see in the lower left corner of the 3D view the 29 marker points on his body. Let's move on to the next step. Let's have him face the coordinate system in the negative direction of the y-axis. Next, I want him to hold his hands up with his toes pointing forward and his head looking straight ahead. If it's purely lower extremity analysis, there are 19 points. Let's look at it from a practical standpoint. If it's purely lower extremity, there are 19 points. Let's look at it from a practical standpoint. After he holds the T-pose, we click on the freeze button at the bottom of the screen. Then we click the right mouse button and select Create Body. In the pop-up window, we select the model with 29 points. Helen Hayes full body with head. If we say without head, we choose full body. For lower body, just choose lower body. For the name, we can give it a name. Enter his initials, then we click on Create. We can see the template, marker-to-marker lines, and the skeleton has been created. Let's click to unfreeze it. You can put your hands down. Where the assets are, there are 2 sets of models we need to keep only one of them. Today I'm going to start with the gait analysis application. For gait analysis, we need to collect a set of static data first, and then we need to collect dynamic data. For static data, we usually use it as a template in software like Visual 3D or Anybody. To find the model to use, we need to pause the playback and click to load the assets. Let's get rid of the dynamic one first. We'll just keep the static one and add some static markers. Let's click play. You need to hold your hands up. We need to recognize it first. This is where you can have the subject turn toward me. Just stand normally. Stand and stay still. Then we need to collect a set of static data. We're going to go down to the file here, and we're going to type in static. We can record 3 to 5 seconds of data. 3 to 5 seconds of data is all we need. We'll click stop just in case. We usually take more than 1 set of data. I'll just take 3 sets here. After the static data is collected, we can pause it. We'll load the dynamic marker template. Then we can have the subject remove the medial knee and ankle markers from the inside of the knee and the inside of the ankle. After removing them, he should have 25 markers on his body. We can hit play and run it. Okay, you can see now we have a dynamic point model. It's dynamic. We're going to change the name of the file below. I'm going to change it to walk. We can now prepare the subject for gait data collection. I can bring him back to the starting point. When the subject is ready, we can click on the record button. You can now start walking. When you're done, we can click to stop recording. For gait data, we can usually capture multiple sets. We can walk to collect more sets. After we stop recording, we can click on the pause button. Click on the post-processing button in the lower left corner. On the right side of the screen, we can open the data we just collected. We can click play to review the data we just collected. If the data looks good, we can click on the file in the upper left corner to export the C3D file. The C3D file can be re-imported into software like Anybody, Bob, or Visual 3D Analysis for further analysis. If we only need the raw data of marker points, we can click the file in the upper left corner. Export the TRC file. We can use Excel to open the corresponding TRC file. You can see the 3D coordinates of each point. These include the 3D coordinates for each frame. Everything is exported. If we want the data for the skeleton, that is the rigid body data, we can export the HTR file. Let's open it in Excel. It contains data for every bone. It's 6 degrees of freedom data. TX/TZ for position, RX and RZ for rotation. These are the Euler angle data. This covers the operations related to capture and export. If we want to get real-time data, we first suggest collecting a set of motion data. Then we click on the file. In the upper left corner, save the model, save the motion capture data. Then we can go back to real-time mode. Click play. In real-time mode, the mannequin can be recognized in real time. You can move it around. At this point, all we need to do is put a message. In the data casting pane, we open the SDK. We can then use our SDK or plugin to get the 3D coordinates of the rigid bodies, or the 3-dimensional coordinates of these points, to perform real-time analysis or applications. This is the introduction to human motion analysis.